Hey guys, we're going to continue our discussion today on the theory of plate tectonics. You guys may recall that the Earth is like a giant egg that's encapsulated by a thin shell. We call that shell, of course, the lithosphere. And that lithosphere is fragmented into 16 or even more lithospheric plates. Of course, the heat within what we call the asthenosphere and the convection cells that transfer that heat is what is causing these plates to move, and they move in relation to each other. Last week, we talked about divergent boundaries. This is when two plates separate. They separate at seafloor spreading zones like a giant conveyor belt where the lava exits the asthenosphere and cools and solidifies into a massive mid-ocean ridge. Well, if we have plates separating, that means they're eventually going to slam into each other somewhere else. And we, of course, call these types of boundaries convergent. There's two types of convergent boundaries. The first type are what we call collisional. This is when two land masses of roughly equal densities collide. A really good example of this is the formation of the Himalayas, the tallest mountain chain on planet Earth, because the subcontinent of India traveled north millions of years ago and, like in a massive automobile accident, collided with Asia. These two land masses, when they collided, had nowhere to go but up, thus creating the longest or the tallest mountain chain above sea level, the Himalayas. Convergent boundaries also occur between oceanic crust, which is more dense, and the less dense continental. This creates what we call subduction zones because the more dense oceanic crust gets pushed down below the less dense continental crust. These subduction zones create the deepest parts of our ocean, sometimes exceeding 11 kilometers in depth. As the oceanic crust gets pushed below, it gets destroyed, creating a lot of heat. And the destruction of that plate creates a lot of magma, which rises to the surface to create volcanic activity along the continental margin. The Andes Mountains formed in this very way. In fact, if we go to the west coast of South America, we can clearly see the Nazca Plate, which is oceanic, subducts or goes below the less dense continental. We know it's subducting because we can look at the symbols in our reference tables that show us without the black boxes, we have the more dense subducting plate, while the overriding plate is the continental plate. That is the plate that has these black boxes on this side of the boundary. So a deep oceanic trench forms at this interface, and this creates volcanic activity and a long volcanic arc of volcanoes that we call the Andes. Sometimes oceanic crust collides with other oceanic crust. This also creates subduction zones. These again are deep oceanic trenches that occur at these boundaries, with the oceanic crust that's older and cooler and more dense being pushed below the less dense crust. This can actually create island arcs, volcanic islands that occur along these boundaries. We can see this along the Ring of Fire. Of course, that elephant tusk that hangs off of Alaska and all of these Aleutian Islands are all volcanic islands associated with subduction along the Aleutian Trench. The Japanese islands and the Marianas Islands are all occurring along these subduction zones where we have more dense oceanic crust going below less dense oceanic crust. So plates that separate and plates that collide create two different types of boundaries, but sometimes they don't separate or come together. Rather, they just sort of slip past each other. We call these transform boundaries or lateral boundaries. These sort of move relative to each other as they slip past each other in a strike-slip fault. A fault is a zone of weakness where the rocks move relative to each other. And this doesn't happen easily. As you can imagine, these are huge slabs of rock, and there's a lot of stress that builds up at these boundaries. When the stress exceeds the resistance along these fault lines, the rock shakes. Seismic activity, what we call earthquake activity, energy is released through the lithosphere that can create catastrophic events that happen at Earth's surface. One of the more famous transform boundaries, of course, is the San Andreas Fault. To get your bearings straight, this is the west coast of the United States. Here's the US, what is known as the North American plate, which is moving in a general southeast direction, while the Pacific plate is grinding to the northwest. Here is a transform boundary modeled by this diagram, where we can see two plates grinding past each other in the opposite direction. And you can also actually see this at Earth's surface. Right, here are some aerial photographs of the San Andreas Fault, which of course was made into a very famous movie starring The Rock, Dwayne Johnson, as the North American plate grinds past the Pacific plate. All right, guys, that's it for today. You're going to be making a model of a convergent and divergent boundary and answering the conclusion questions. We'll see you soon.